Hello everyone, this is Aditya Mahajan. Welcome back to my channel. As we all know, we are facing a very unfortunate event. A virus had earlier been detected in China. It has already made its way and killed 100,000 people. Many more are infected. As I speak, many more will continue to be infected. So as you all know, we are in a lockdown. At least India and many other countries are in a lockdown, and so you might be wondering when you want to return to your normal life. And so there's only one thing that can help us in returning to normalcy. That is a cure. Now you might be wondering, the cures is so easy to make. Why hasn't it been made yet? The virus started in January and it's April. 4 months have passed. What were scientists doing? Now that those were the questions that I was wondering too. But now you see, making a cure is not that easy. A cure takes lots of time to make, and that is what I will be covering today. So, to understand how a cure or a vaccine is made, we need to be understanding the structure of a virus. And, in the end, our objective is to kill the virus, right? So, as you know, this virus, it has these spikes. They are made up of protein, and this envelope protein, and this envelope, they're both made up of proteins and fats. And now these fats and proteins, they may not be they able to like go away from with water, but if you wash your hands with soap and water, then it's guaranteed these viruses will go away from your hands, at least your hand for now. And if we go inside the virus, this is the genome of the virus. This is basically the DNA of the virus. On January 8th, the Wall Street Journal America detected this virus. So we can presume that the first case came in January 4th. Why January 4th? Because the incubation period of this virus, at least for now, is 4 days. So what is 14 days? Sorry, not 4 days. I made a mistake there. 14 days. Uh, so we can assume this virus, it infected its first person in like the end of December, and then it was detected in January 8th. Now China gave this virus the sequence of the virus to the world. Now, how did it give the sequence? This is the genome. It gave this genome to the virus to the whole world, and this is very important. The nucleopacid and viral tegument, they are not so important, and we don't need to worry about them. As you can see, this is your normal virus. And so now we come to the point of our today's topic, and that is a cure. Now there are three to four methods to making a cure. One is the old school method, the method that was very famous like 40 to 60 years ago. So what happened in this was, you kill and weaken the virus using some methods, and then inject it to the body, inject it inside the body. Now what happens here is, the body, since this virus is very very weak, the body rushes and it responds very strongly, very harshly, and so it makes a cure. It makes antibodies that can finish the virus off. And so when if God forbid it, but if this virus comes in your body will know the cure, and then it would automatically kill the virus. Now this was the first method. Now the second method is the modern method, which we do follow, but there are some other methods to replace this. Now this is synthetic modification of the virus. Uh, this method and the old school method that was followed many years ago, 40 to 50 years ago, 4 decades ago, they are pretty much the same, but there are some modifications in this method. So in this virus, you don't you engineer the virus, like as I talked about earlier. This viral genome, you engineer the virus using its viral genome, and then you kill the protein and inject it into the body. The same thing happens. The body creates a virus, just but in this you just engineer the virus. You don't find it like from places. Now, the third method. The third method is the fanciest of all methods. It's very sophisticated, and this method, it's very useful and very important. Now, so it's very new, this method. So this is the messenger RNA. Forgive me, this is A, but it should be E. I didn't notice that. This is the messenger RNA method. So you inject some RNAs into the body. Now what they do is they do something very new here. Now they give instructions to your body cells, to the body, and so they go in the body. They tell the body, hey, something new, a new enemy, your new enemy is approaching. You need these missiles to fight it. You don't have them as of yet. Please make these things. And the body, which is like very good and very great, starts creating these. So this is messenger RNA. Now this is in which you insert the DNA of the virus. So the DNA, so its name is the naked DNA. Why is it called the naked DNA? Because you just inject the DNA of the virus, and like the first and second methods, the same thing happens. The body finds out the cure, and when it actually happens, the body knows how to do it. Now we come to the fifth method. The fifth method is a bacterial method. So these bacteria, they contain killed or annihilated bacteria that activate the immune system. So what happens is this is it's a bit similar to the first and second, but it's not so entirely similar. So what happens in the bacterial method is that it tells the body. No, well, not like the messenger RNA. It like gives waves to the body, wave transmission to the body. But in bacterial method, what happens is it kills the it goes to the body and tells them to like ramp up production of the antibodies. And when the virus happens to you, what happens is your body has made so many antibodies, this virus eventually dies, because your body, these antibodies of the body will eventually overpower the virus and it will die. Now, these were the methods of how a vaccine is made. But you must be wondering, why does it take so long? I mean, this virus came in January or in December, but now it's April. It's almost been 4 months. So if you can take any vaccine, there are what happens is there are 3 phases in human trials. Okay, so first is what happens is you first start testing your vaccine upon animals, and if it's successful and if the results are very good and positive, you will get some sort of confirmation, and then you can carry out tests on humans. So there will be some brave volunteers of humans, and so what happens is they volunteer, and there are 3 phases. And before they volunteer, let me tell you that there are 3 phases in human testing. Okay, actually there's nothing different in these phases, but it just differs the amount of people you have tested. So first, what happens is once you give these people some vaccines, the vaccine, you let them, you send them somewhere, and after some time you notice if there are any side effects, if there are some bad side effects of this virus and this vaccine. If nothing too bad happens, then you come to phase 2. Then okay, so in phase 1 you gave this vaccine to about 20 to 30 people, but in phase 2 you give this vaccine to about 200-300 people. Same thing happens, you observe them, and if everything's good, if everything's cool like me, then you proceed to phase 3. Now in phase 3, what happens is you like pass this vaccine to a larger amount of people, a good big community of people, like 2,000, 4,000, 10,000 people. And so if everything is cool with them and if nothing bad happens, then you basically give it to the rest of the world. Now there are now this is basically how vaccines are made and why it takes so long. AIMS just like they told us that it would take 12 to 18 months. So next time if something like that happens, so don't get angry why it takes 12 to 18 months. It just happens. So this brings us to the end of our topic, and I would just like to give you some fun facts about what's happening. 60 of these vaccines have been made, but only 2 have neared, these human testing. So I hope you enjoyed this video, and if you liked it, please like and subscribe and pass it on to your friends, family, and that brings us to the end of the video. Bye.